So in the previous class we have shown that intersection of subgroups is a subgroup. So the natural question that comes in our mind is whether union of subgroups will be a subgroup or not. So let us think on it. So let us say G is a group and H and K are actually subgroups of G. So the question in our mind is, will H union K be a subgroup of G? So as you can see, this is a proof of the intersection of subgroups. So this is actually the overlapping part is nothing but H intersection K. So what will be my H union K? So entire thing, right? The elements of H as well as the elements of K. This entire thing is nothing but my H union K. So H union K. So now if we are successfully able to prove H union K is non-empty, H union K is a subset of G and the condition, then we can conclude that the union of two subgroups is a subgroup. So let us think on it. So again now we have to prove that H union K is also a subgroup of G. In fact we are checking, right, because we are not sure whether it will be a subgroup or not. Okay, is H union K a subgroup of G, right? That should be the right question. So again the given things, G is a group, H and K are subgroups of G and we are checking, right? So I'll say, okay, to check whether this H union K is a subgroup of G or not. Again the reasoning remains exactly the same. So as H is a subgroup of G, E will belong to H. As K is a subgroup of G, E will belong to K as well, and therefore this E will be in H union K also. Remember, H union K either contains an element of H or an element of K. So this E belongs to H union K and therefore H union K is actually non-empty. No issues with that. Subset, again no issues because H and K entirely lies in G, so H union K will also lie in G. So that is also not a problem to us. So now we will start with two elements of H union K. Now here is a trick. Here we have to think, right? So AB are the two elements in H union K. So does it imply AB lies in H? Both. That is what we have to think. So AB is in H union K. So it may happen that A is entirely in H and B is entirely in K, right? This may happen. So this doesn't actually imply that AB lies in H, isn't it? Because H contains only A and not B, right? So therefore from here to here we are having a issue. So AB belongs to H union K does not imply AB belongs to H, right? So the next question is then, when will be union of two subgroups a subgroup? In other words, if AB lie in H union K, then when this both elements AB will lie in H or the both elements will lie in K. If this thing happens, AB are either in H or AB are either in K, then we are completely fine with that, right? And if you think properly, so what should actually happen is, So let us say this is my H, right? And let us say this is my K. So, and this completely is my H. Now, if I take two elements of H union K, now my H union K is nothing but this part. So if I take two elements, let us say A and B from H union K, let us say A lies here and let us say B lies here, still we can say that both A and B lie in H. Am I right? Because K is actually a subset of H. Other way around may also happen. This inside one can be H and the outside one can be K as well. So the logic remains the same. So if I take A and B, two elements from H union K, still now the A and B, two elements lies in what? K now. Thus, what is our conclusion? Union of two subgroups is a subgroup if and only if in fact one is subset of other, and that is exactly what we are going to prove.